Hi all, welcome to Anil Nair classes. Today in this session, we are going to discuss reminders based on factorials. Those who are regularly watching my classes, we discussed factorials session 1, where the definition of a factorial, I defined what are the possible unit digits for a factorial. We discussed how to check whether the factorial sum is divided by a particular number. We checked and we did some very good problems based on factorial, that is summation n into n factorial is nothing but n plus 1 factorial minus 1. All basic problems we did it in factorials session 1. Now today's session is a factorials session 2. Factorials session 2. In this session 2, I am only going to discuss reminders based on factorials. All the questions that I am going to discuss will have factorial as a part of the problem, and that numerator is divided by denominator. We have to find out the remainder when a numerator is divided by denominator. All the questions, whatever we are going to discuss will be of the form numerator when divided by denominator, remainder. These numerator will have factorial as a part of it. Will have factorial as a part of it. Will have factorial as a part of it. Very interesting class. We will discuss one by one the traditional method as well as the optimal method. Numerator by denominator. First we will discuss what will happen if the denominator is a prime number today. Then we will take the prime number multiples. So it is part 1. We will discuss for a prime number and we will discuss for the multiples of a prime number. Straight away let us get into the class. Do not leave in between. I will start from basics of all the questions related to this topic. Slowly I will take you to a very advanced level. Session 2 is the reminders based on factorials. Before we discuss this one, first we will write down the question. All the reminders where it is based on factorials, there is a method that we are going to use, that is Wilson's theorem. Wilson's theorem is used to find the remainder based problems when the factorials are divided by a prime number. Wilson's theorem is used when the denominator is a prime number. Wilson's theorem is used when the denominator is a prime number and the numerator is nothing but a factorial format. If the numerator is in a factorial format and the denominator is a prime number, you can use Wilson's theorem. What is a Wilson's theorem? Wilson has proposed a beautiful theorem to solve some of the toughest remainder problems using this notation. P minus 1 factorial plus 1 when divided by P, it is always 0 when P is a prime number. Reminder when P minus 1 factorial plus 1 when divided by P, it is always 0 when P is a prime number. Wilson's theorem is used when the denominator is a prime number. For example, if I take P value 5, this will become 5 minus 1 is 4 factorial plus 1 when divided by 5. 24 plus 1 is 25. 25 when divided by 5. Remainder is 0. P minus 1 factorial plus 1 when divided by P. Remainder is 0 as long as P is a prime number. P minus 1 factorial plus 1 when divided by P, remainder is 0 when P is a prime number. All the questions whatever I am discussing today are either taken from the primitive concept or taken from the derived concept of Wilson's theorem. All the questions are based on reminders based on factorials. Let us straight away get into the class. Kindly sit in the class with a notebook and a pen or a pencil. Watch the entire lecture so that any doubt that you got will get erased as the class proceeds. In case if you got any mail, send us a mail all your doubts at support@anilnairclasses.com. At the end of the class, you will be able to solve some of the toughest problems under this topic without the usage of pen and pencil. Right? Those of you who are relatively new to the class, I might have taken more than 1000 students, minimum 500 students. In a class, more than 500, 700, 1000, 2000, 3000, that will be the class. I stopped taking the students count as 500 some years before. Now my classroom strength will be anything greater than or equivalent to 1000. Right? We'll straight away get into the topic. First one. First we'll write down the concept. What is the concept? Reminder 1. P minus 1 factorial plus 1 when divided by p is 0 when p is a prime number. This is the first concept. This is the first concept. Second concept, if I take negative remainder, 13 when divided by 4, 4 3s are 12. What is the positive remainder? Positive remainder is 1. What is the negative remainder? 4 4s are 16. It is minus 3. Are you all with me? If you get a negative remainder, add it with the denominator to get the positive remainder. If you got the negative remainder, add with the denominator to get the positive remainder. This concept is extremely important. If the answer came out to be a negative remainder, add it with the denominator to get the positive remainder. If you got the negative remainder, add it with the denominator to get the positive remainder. These two concepts I am going to use. Extremely important concept. Positive remainder means answer will be like this. If you got a negative remainder, add it with the denominator to get the positive remainder. First question. Remainder 1. 30 factorial divided by 31. This can be written as 31 factorial is nothing. 30 factorial is 31 minus 1 factorial. I am adding 1 and subtracting 1 when divided by 31. 31 minus 1 factorial plus 1 minus 1. P minus 1 factorial plus 1 when divided by P. What is the negative remainder? It is minus 1 because this came out to be 0. Negative remainder minus 1. Positive remainder is 30. I hope it is clear. Remainder when p minus 1 factorial plus 1 when divided by p is 0 when p is a prime number. So 30 factorial is 31 minus 1 factorial plus 1 minus 1. P minus 1 factorial plus 1 divided by p is 0. Negative remainder minus 1. Positive remainder will be 30. Whenever you get the negative remainder, add it with the denominator to get the positive remainder. You don't need to do all this. Suppose if I put plus 1, this p minus 1 5 factorial. Plus 1 if it comes to this side, what it will become? Minus 1. That only we will write it. Directly we will write the important key point so that you don't need to waste time. What is the conclusion? Remainder 1. P minus 1 factorial plus 1 when divided by p it is 0. So plus 1 if it comes to the right hand side, p minus 1 factorial when divided by p it is minus 1. Negative remainder means add it with the denominator p minus 1. So that means if p minus 1 factorial is divided by p, remainder will be p minus 1. P minus 1 factorial when divided by p, negative answer will be p minus 1. So you don't need to write it, directly you can write 30 factorial by 31 is 31 minus 1 is 30. Similarly, remainder 1. 72 factorial divided by 73 is 73 minus 1 72. P minus 1 factorial when divided by p is p minus 1. P minus 1 factorial when divided by p is p minus 1. Very important conclusion derived from the Wilson's theorem. Now you might ask a doubt, Anil sir, what will happen if it is p minus 2, p minus 3? Slowly we will discuss the derivative of all these problems. I hope the concept is clear. Now directly you can say remainder when p minus 1 factorial divided by p, which is nothing but p minus 1. These when the p is a prime number. These when the p is a prime number. So if I start using this concept, 16 factorial by 17 is 17 minus 1 16. I hope the idea is clear. Idea is clear. Numerator it is p minus 1 factorial, denominator it is p. This is the concept. P minus 1 factorial when divided by p. Now another beautiful question. Find the remainder when 15 factorial divided by 17. 15 factorial divided by 17. Now first important observation. 15 factorial is 15 into 14 into 13 and so on up to 2 into 1. 17. There is no factor common that is present in 15 factorial and 17. 15 factorial and 17 are co-prime numbers. Are you all with me? Are co-prime numbers. Are co-prime numbers. Co-prime numbers. Now if you see remainder 9 divided by 2. 2 4s are 8, remainder 1. Remainder 18 is divided by 4. 4 4s are 16. What is the remainder? 2. Here 9 and 2 are co-prime to each other. I got a remainder 1. 18 and 4 are not co-prime to each other. The remainder is getting affected. Remainder is getting affected when the numerator and denominator are not becoming co-primes. That means if you solve this question like this, remainder 1 16 into 15 factorial by 16 into 17, because n factorial is n into n minus 1 factorial, you might get an idea that can I write like this. But if you take these two, 16 is common to each other. That means numbers are not co-prime to each other. This logic is not applicable when the numerator and denominator are not co-prime. Remainder will get affected. So here it is a wrong method. Don't multiply and divide by 16. If you multiply and divide by 16, numerator and denominator will not be co-prime to each other. I want it to be co-prime to each other. So this method of multiplying and dividing by 16 should not work. Now see here. How to do it? Remainder 1, we have already discussed. 16 factorial divided by 17 is 16. Already we know. What is the concept? Remainder 1, p minus 1 factorial divided by p. It is nothing but p minus 1. So 16 factorial is nothing but 16 into 15 factorial when divided by 17 is 16. Till here it is clear. Now if you observe, remainder 1, 9 into 7 divided by 2. 9 when divided by 2, remainder 1. 7 when divided by 2, remainder 1. When I further divide, is the remainder changing? Remainder is not changing. It will not change as long as the numerator is less than the denominator. 16 when divided by 17. 17 zeros are 0. 16. 15 factorial by 17. We don't know the remainder. When I further divide, remainder will not change. Just by looking at a question itself, I can say that x equivalent to 1. Because 16 ones are 16. 16 divided by 17 is 16. By looking at a question itself, I am able to deduce 16 factorial divided by 17 is 16. What is the method that I am using in this one? I am using backtracking method. I am using backtracking method. From the known, I am determining the unknown. 16 factorial by 17 is 16. 16 factorial is 16 into 15 factorial. 16 by 17 is 16. 15 factorial by 17, I don't know. So I call it as x. When I further divide, remainder will not change. It is explained in this example. 9 when divided by 2, 1. 7 when divided by 2, 1. When I further divide, remainder will not change. Idea clear? Idea, I hope it is clear. Right? You don't need to do all this. There is a beautiful shortcut which I will explain after I solve the next problem. right? Now find the remainder when 27 factorial divided by 29. 27 factorial divided by 29. We know that remainder when 28 factorial divided by 29 is 28, because remainder when p minus 1 factorial when divided by p, it is nothing but p minus 1 when p is a prime number. When p is a prime number. So 28 factorial is nothing but 28 into 27 factorial when divided by 29, it is nothing but 28. These is nothing but 28. 27 factorial divided by 29, I don't know. When I further divide, remainder will not change. Just by looking at a question itself, I can say that x equivalent to 1. I can say that x equivalent to 1. Are you all with me? In the previous case also we got 1. In this case also we got 1. Does it mean that p minus 2 factorial divided by p, it will always result in 1? Definitely it will result in 1. Now see, why it will result in 1? Right? Because of these two examples it is concluded. So conclusion. Remainder when p minus 2 factorial divided by p, it is always 1 when p is a prime number. Important conclusion. Remainder when p minus 2 factorial when divided by p, remainder is always 1 when p is a prime number. That means remainder, the difference in the numerator and denominator, the term value should be 2. 27 factorial divided by 29, it is 1. Remainder when 41 factorial divided by 43, these also 1. Remainder when 27 factorial divided by 29 or 77 factorial divided by 79, it is also 1. Idea clear? P minus 2 factorial when divided by p, it is always 1 when p is a prime number. First conclusion, p minus 1 factorial divided by p is p minus 1. P minus 2 factorial divided by p, it is always 1 when p is a prime number. Next, is 41 factorial minus 1 prime or composite? What is the concept we discussed just now? P minus 2 factorial divided by p, it is always 1 when p is a prime number. When p is a prime number. So if I use this concept, remainder of 41 factorial divided by 43, it is always 1. So if the question is 41 factorial minus 1 when divided by 43, here it is 1. 1 minus 1 is 0. That means 41 factorial minus 1 is divisible by 43. Are you all with me? Seems like a very difficult question, but actually it's an easy question. 41 factorial minus 1 is divisible by 43. Hence 41 factorial minus 1 is a composite number. Hence this number is a composite number. I hope the idea is clear. What is the concept that I used in this question? P minus 2 factorial when divided by p, it is 1. Based upon that one, 41 factorial by 43, it is 1. 41 factorial minus 1. 41 factorial by 43 is 1. 1 minus 1 is 0. So 41 factorial minus 1 is a composite number. Idea clear? All are conceptual understanding questions. If you know the concept, you can crack it very fast. If you do not know the concept, you will say that this question is very difficult. Is 18 factorial plus 1 prime or composite? Always look out for that number. P minus 1 factorial divided by p is p minus 1 when p is a prime number. When p is a prime number. So this will become 18 factorial by 19, which is nothing but 19 minus 1, 18. But I require 18 factorial plus 1 divided by 19. This value is 18. 18 plus 1, 19. 19 divided by 19, remainder 0. That means 18 factorial plus 1 is divisible by 19. 18 factorial plus 1 is divisible by 19. Therefore, 18 factorial plus 1, it is a composite number. 18 factorial plus 1, it is a composite number. Idea clear, right? Very easy questions if you know it. If you don't know it, you will say that how to check whether a number is a prime number or not. Next one, find the remainder when 40 factorial is divided by 43. Very, very good question. For using p minus 2 factorial, I used p minus 1 factorial. Similarly, remainder 1, p minus 2 factorial divided by p, we got 1. I will use this concept when p is the prime number. If p is the prime number. If I use this concept, 43 minus 2 is 41 factorial. 41 factorial divided by 43 is 1. Till here it is clear. 41 factorial is nothing but 41 into 40 factorial divided by 43, it is 1. I hope this is clear. 41 divided by 43 is 41. 40 factorial divided by 43 is x. When I further divide by 43, remainder will not change. Remainder will not change. Till here clear? 41x is divided by 43. We don't know the quotient, but we know that the remainder is 1. Are you all with me? So, 9 when divided by 2, 2 4s are 8, remainder 1. So, 9 is 2 into 4 plus 1. Similarly, here it will be. Listen carefully, sir. Very, very good questions. 41x equivalent to 43k plus 1. So, 41x is nothing but 41k plus 2k plus 1. These is divisible by 41. These is divisible by 41. 2k plus 1 should be divisible by 41. So, k value is nothing but 20. If k value is nothing but 20, if I substitute it, 41x equivalent to 43, 1, 2, 6, 1. So, x equivalent to 41, 3s are 120. I hope it is clear, right? K is 20. So, 1260. 41x equivalent to 43k plus 1. 41x is 43k plus 1. 41x equivalent to 41k plus 2k plus 1. This should be divisible by 41. I hope it is clear. 41 factorial. 41 factorial divided by 43 is 1. 41 factorial is 41 into 40 factorial by 43. These are nothing but 41. So 40 factorial by 43 is x. 41x by 43 is 1. 41x is 43k plus 1. 41x plus 2k plus 1. Divisible by 41, divisible by 41. 2k plus 1 is 41, k20. If I substitute k20, 43 into 20 is 860 plus 1, 861. So, these is nothing but x is 21. X is 21. I hope the idea is clear. There is also a shortcut for that which we will discuss. What are the concepts that we used? Dividend equivalent to divisor into quotient plus remainder. These divisible by 41, divisible by 41. This should be divisible by 41. That means k value is 20. 43 into 20 plus 1, 861. So, x value is 21. Idea clear? I will do one more question. Then I will tell you the shortcut. See here, this question. Find the remainder when 16 factorial is divided by 19. Remainder when p minus 2 factorial when divided by p, it is 1. This one p is a prime number. This one p is a prime number. These 17 factorial divided by 19, it is 1. 17 factorial is 17 into 16 factorial when divided by 19, it is 1. 17 divided by 19, remainder is 17. 16 factorial by 19 is x. When I further divide, remainder will not change. 17x is dividend, it is getting divided by 19. Quotient we don't know, remainder is 1. So dividend equivalent to divisor into quotient plus remainder. 17x is 17k plus 2k plus 1. Divisible by 17, divisible by 17. 2k plus 1 should be divisible by 17. K value is 8. If I substitute here, 17x is 152 plus 1, 153. X value is 9. X value is 9. I hope the idea is clear. Remainder 1. P minus 2 factorial divided by P, it is 1 when the P is a prime number. Again, what I used in this question? I used backtracking method in this question. Right? P minus 2 factorial by P is 1. 17 factorial by 19 is 1. From there I went. This is a very long method. Directly you can tell the answer if you know the approach. I hope this approach is clear. Now there is a better approach. Concept is remainder 1. P minus 3 factorial when divided by P. The value came out to be P minus 1 by 2 when P is a prime number. So this is nothing but 19 minus 3, 16 factorial divided by 19. 19 minus 1, 18. 18 by 2 is 9. Directly you can say the answer. Suppose if the question is remainder 1, 20 factorial divided by 23. 23 minus 1, 22. 22 by 2 is 11. It's all direct calculation. 70 factorial by 73. 73 minus 1, 72 by 2, 36. If the question is remainder 1, 14 factorial divided by 17. 17 minus 1, 16. 16 by 2, 8. Extremely important concept. Remainder 1. P minus 3 factorial when divided by P, the answer comes out to be P minus 1 by 2 when P is a prime number. P minus 1 factorial by P is P minus 1. P minus 2 factorial by P is 1. P minus 3 factorial when divided by P is P minus 1 by 2. I hope the concept is clear. Now see here. Now the difference is 4. Find the remainder 1. 97 factorial is divided by 101. Just now we discussed these where these optimal techniques are useful. P minus 3 factorial. P minus 3 factorial when divided by P is P minus 1 by 2 when P is a prime number. So these are nothing but 101 minus 3. 98 factorial divided by 101 is 101 minus 100. 100 by 2 is 50. 98 factorial is nothing but 98 into 97 factorial divided by 101 is 50. 98 divided by 101 is 98. 97 factorial divided by 101 is x. When divided by 101, remainder is nothing but 50. 98x when divided by 101, remainder is 50. Dividend equivalent to divisor into quotient plus remainder. So 98x equivalent to 101k plus 50. 98x equivalent to 98k plus 3k plus 50. 90x 80 is divisible by 98. These also divisible by 98. 3k plus 50 is divisible by, should be divisible by 98. So k value will be 16. K value will be 16. So here it will become, if I substitute 98x equivalent to 101 into 16 plus 50. So x is nothing but 1666 divided by 98. 98 ones are 98. 98 ones are 98. So 2, 686. 686. Whatever the answer that you will get, that itself is the answer. I hope it is clear, right? Idea clear? P minus 1 factorial by P, we did it. P minus 2 factorial by P, we did it. P minus 3 factorial by P is P minus 1 by 2. I hope the idea is till here clear, right? So what we got, 98 divisible by 98, 3k plus 50, 98, k is 16. So 16 plus 50, 1666 divided by 98. Whatever the answer that you will get, that itself is the answer. So 7 14s are, 7 2s are 14, 26, 7 3s are 21, 8, right? So 14, 17s are, answer is 17, right? You can deduce your own P minus 4 factorial by P. How much? Just by few observational analysis. I hope the idea is clear. Next one, find the remainder when 17 factorial is divided by 23. We are still going very deep. Find the remainder when 17 factorial is divided by 23. We know the logic that remainder when P minus 3 factorial when divided by P, it is nothing but P minus 1 by 2 when P is a prime number. When P is a prime number. So this will become 20 factorial by 23. It is nothing but 22 by 2, which is 11. 20 factorial is nothing but 20 into 19 into 18 into 17 factorial when divided by 23. It is 11. 20, 23 ones are 23 minus 3. 23 ones are 23 minus 4. 23 ones are 23 minus 5 into x when divided by 23 is 11. These remainder of 60x. 23 3s are 69 minus 9. Minus into minus 9. 9x divided by 23, it is 11. I hope till here it is clear. P minus 3 factorial when divided by P is P minus 1 by 2. 20 factorial by 23 is 22 by 2, which is 11. 20 factorial is 20 into 19 into 18 into 17 factorial by 23. 23 ones are 23 minus 3 minus 4 minus 5 into x divided by 23 is 11. 60 is 23, 3s are 69 minus 9. Now from here you can solve this one. 9x is nothing but 23k plus 11. So 9x is nothing but 18k plus 9 plus 5k plus 2. Divisible by 9, divisible by 9, divisible by 9. 5k plus 2 should be divisible by 9. It cannot be 9 because k value will be fraction. It cannot be 18. It has to be 27. So k value is 5. 5k plus 2, 27, k value 5. Substitute there. If I substitute there, 9x is 23 5s are 115 plus 11, 126. So x value is nothing but 14. X value is nothing but 14. Very, very good quality questions from the topic reminders based on factorials we are discussing. 17 factorial divided by 23. 20 factorial divided by 23 is 11. 20 factorial is 20 into 19 into 18 into 17 factorial by 23. 20 by 23 is minus 3 minus 4 minus 5 into x divided by 23 is 11. 60 divided by 23 is 23 3s are 69 minus of minus is plus. 9x divided by 23 is 11. 9x is 23k plus 11. 9x is 18k plus 9 plus 5k plus 2. Divisible by 9, divisible by 9, divisible by 9. 5k plus 2 should be divisible by 9. The only value which will be of the form 5k plus 2 and divisible by 9 is 27. K will become 5. Substitute it, you got x value 14. Very starting from basics to an high level. Next one, find the remainder when 23 factorial is divided by 17. 23 factorial is nothing but 23, 22, 21 and so on up to 17 and so on up to 1 when divided by 17. Any number multiplied by 17 when divided by 17, answer is 0. Or in other words, you can easily say that remainder when x factorial divided by n is 0 if n is a factor of x factorial. If n is a factor of x factorial, remainder when x factorial divided by n is 0. Remainder when x factorial when divided by n is 0 when n is a factor of x factorial. I hope this idea is clear. Idea is clear, right? X factorial divided by n is 0 when n is a factor of x factorial. Another question. Now we will discuss the next level of questions. Find the remainder when 18 factorial is divided by 437. First we have to factorize 437. 437 is 19. 2s are 38, 50s. 19 3s are 8. 437 is 19 by 23. So what are the concepts that we are going to use here? Remainder when 18 factorial by 19 we have to do, and remainder when 18 factorial divided by 23 we have to do, and then we have to find the equations. So 18 factorial divided by 19 is nothing but 18. P minus 1 factorial when divided by P. 18 factorial divided by 23. 20 factorial divided by 23 is nothing but 11. Why? Because it is of the form P minus 1 by 2. 20 factorial is 20 into 19 into 18 factorial divided by 23, it is 11. 20 divided by 23 is minus 3. It is minus 4. 18 factorial divided by 23 is x. When I further divide by 23, remainder is 11. Minus into minus plus. Remainder when 12x divided by 23, it is nothing but 11. So here it is dividend equivalent to divisor into quotient plus remainder. So here it is 12x is nothing but 24k plus 12 plus or minus of 1 plus k. Till here it is clear. 12x equivalent to 24k plus 12 minus of 1 plus k. Till here it is clear, right? 12x is nothing. When divided by 23, remainder is 11. This I wrote it as 12x equivalent to 24k plus 12 minus of 1 plus k. Right? These is divisible by 12. These is divisible by 12. These is divisible by 12. 1 plus k should be divisible by 12. That means k value should be 11. K value should be 11. So 12x is nothing but 23 into 11 plus 11, which is nothing but 24 into 11. So x value is nothing but 22. Are you all with me? X value is nothing but 22. That means two equations we got. 18 factorial divided by 19 is 18 we got. 18 factorial when divided by 23 we got it as 22. Now we will try to solve these two equations. 18 factorial divided by 19 is 18 we got. 18 factorial divided by 23 we got it as how much we got? 22. So both the equations are 18 factorial when divided by 19, remainder 18. 18 factorial when divided by 23, remainder is 22. So if I equate both the equations, 19a plus 18 equivalent to 23b plus 22. So 19a equivalent to 23b plus 4. These is nothing but 19a equivalent to 19b plus 4 into b plus 1. Divisible by 19, divisible by 19. 4 into b plus 1. 4 is not divisible by 19. B value is 18. B value is 18. If B value is 18, answer is nothing but 23 into 18 plus 22. When divided by 19, I will get the answer. Are you all with me, sir? So 23 into 18 plus 22. How to find out the value of B? Is it clear, right? 18 factorial by 19 is 18. 18 factorial by 23 is 22. Both will represent same number. 19a plus 18, 23b plus 22, 23b plus 4. 19a is 19b plus 4 into b plus 1. Divisible by 19, divisible by 19. B is 18. If B is 18, 23 into 18 plus 22 divided by, not 19, divided by 437. Whatever the value that you get it, that itself is the answer. This question is a combination of the product of two prime numbers 19 and 23. This is a combination of two prime numbers 19 and 23. I hope the logic is clear. Another one. Find the remainder when 216 factorial. Now if you see remainder when p minus 1 factorial when divided by p, this is nothing but p minus 1 when p is a prime number. Same concept we will use it here. 2016 factorial power 2015 factorial divided by 2017. 2017 is a prime number. I will tell you in prime number session 1 how to check whether a number is a prime or composite. These is nothing but p minus 1. So these 2000 p minus 1 factorial divided by p, it is nothing but p minus 1. So these are nothing but remainder of 2016 power 2015 factorial divided by 2017. 2017 ones are 1 minus 1. This is an even number. Minus 1 power even number is plus 1. Minus 1 power even number is plus 1. Minus 1 power even number is plus 1. Idea clear? Remainder when p minus 1 factorial divided by p, it is p minus 1. 2016 factorial by 2017 is 2016. 2016 by 2017 is minus 1. 2015 factorial is an even number. Minus 1 power even number is plus 1. Another variety of question. Another question. These are all very, very good questions, sir. Question is, find the remainder when 8 factorial whole square divided by 17. 8 factorial whole square divided by 17. I will solve the first one, second one you can try it out. 15 factorial divided by 17 is 1. 15 factorial is nothing but 1, 2, 3 and so on up to 8 into 9, 10, 11, 12, 13, 14, 15 divided by 17. These also 1. 1 into 2 into 3 till 8 is nothing but 8 factorial. Are you all with me? 9 divided by 17 is minus 8. 10 divided by 17. 17 ones are 17. Minus 7. 11 divided by 17 is minus 6. 15 divided by 17 is minus 2. When I further divide, remainder will not change. From 2 to 8, there are 7 negatives. 7 negatives, if I multiply, it will be negative. So minus remainder of 8 factorial whole square divided by 17 is 1. So minus, if I do it, 1 will become minus 1. Minus 1 means it becomes 16. Answer for this question is 16. Answer for this question is 16. I hope the idea is clear. 8 factorial whole square divided by 17. 15 factorial divided by 17. P minus 2 factorial when divided by P is 1. 15 factorial is 1 to 15. 1 into 2 into 3 till 8 is 8 factorial. Minus 8, minus 7, minus 6, minus 2. 2 to 8 there are 7 negatives. 7 negatives, if I multiply, I will get negative sign. 8 factorial into 8 factorial, 8 factorial. Minus is outside. If I multiply by minus 1, I will get positive remainder is 16. Positive remainder is 16. Idea clear? One more question which we will solve. Remainder 1. 35 factorial whole square when divided by 71. 35 factorial whole square divided by 71. So these are nothing but 69 factorial divided by 71 is 1. P minus 2 factorial when divided by P is 1. 69 is nothing but 1 into 2 into 3 till 35. Remaining will be 36, 37 till 69. When divided by 71, it is 1. 1 into 2 into 3 till 35 is 35 factorial. 36 divided by 71 is minus 35. 37 divided by 71 is minus 34. 69 divided by 71 is minus 2. Divided by 71, it is 1. 2 to 35, there are 34 negatives. If you multiply 34 negatives, I will get a positive. So answer is nothing but remainder 1. 35 factorial whole square divided by 71 is 1. 35 whole square divided by 71 is 1. The difference between this question and previous question is, there I got odd number of negatives. Odd number of negatives, if I multiply, I will get a negative. Even number of negatives, if I multiply, I will get positive. Very, very quality questions. All the questions are based on reminders, based on factorials. 69 factorial divided by 71 is 1. 1 into 2 till 35. I did till 35 because the question is till 35. 36 to 69. 35 factorial. 36 by 71 is minus 35. Minus 34. 69 by 71 is minus 2. From 2 to 35 there are 34 negatives. 34 negatives, if I multiply, I will get a positive. Idea clear, right? Another question. 270 factorial whole square divided by 541. 541. Now see here. Remainder 1. 270 factorial whole square divided by 541. So this will become, if I do 2, 539 factorial divided by 541. It is nothing but 1. 539 factorial divided by 541 is 1. 539 can be written as 1 into till 270, 271, 272 and so on up to 539. Divided by 541, it is 1. So here it is nothing but 1 into 2 till 270 is 270 factorial. 270 factorial. 271 by 541 minus 270. I hope it is clear. It is minus 269 and so on up to 539 divided by 541 is minus 2 divided by 541. From 2 to 270, there are 269 negatives are there. If you multiply odd number of negatives, I will get a negative. So outside minus will be there. Minus of 270 factorial whole square by 541, which is nothing but 1. Multiply with negative on both the sides. Answer for this question is 540. Answer for this question is 540. I hope the idea is clear. First we are doing p minus 2 factorial divided by p is 1. From there we are trying to find out the squares. Answer is 540. This question and previous two questions are of the same model. I hope the idea is clear. Next one, find the remainder 1. 1 into 1 factorial, 2 into 2 factorial and so on up to 45 into 5 factorial. In session 1 we discussed n into n factorial, n equivalent to 1 to n. It is nothing but n plus 1 factorial minus 1. I gave the proof in the first class. So this is nothing but 45 into 45 factorial. It is n equivalent to 1 to 45. This is nothing but 46 factorial minus 1. So here it is nothing but when you divide 46 factorial minus 1 divided by 47. These p minus 1 factorial. P minus 1 factorial when divided by p, it is nothing but p minus 1. So 46 minus 1. Answer for this question is 45. Answer for this question is 45. I hope the idea is clear. N into n factorial, it is nothing but n plus 1 factorial minus 1. 45 into 45 factorial is 46 factorial minus 1. 46 factorial minus 1 when divided by 47. P minus 1 factorial divided by p is p minus 1. So 47 minus 1 is 46. 46 minus 1 is 45. Idea clear, right? Same, another model. N into n factorial. From n equivalent to 1 to n is nothing but n plus 1 factorial minus 1. So these is nothing but 14 into 14 factorial. N equivalent to 1 to 14 is nothing but 15 factorial minus 1. Now the difference is 2. Remainder 1. 15 factorial minus 1 when divided by 17. This is 1. Why? Because remainder 1. P minus 2 factorial when divided by p, it is 1. 1 minus 1 0. 1 minus 1 0. I hope the idea is clear. Previous question it is p minus 1 factorial by p. Now the question is p minus 2 factorial by p. Variety of questions we are solving under that subtopic. Reminders based on factorials. Reminders based on factorials. I hope it is clear. One more question. There is a number 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on up to 1 by 23. It is a by 23 factorial. So a will become 23 factorial plus 23 factorial by 2 plus 23 factorial by 3 plus 23 factorial by 4 and so on up to 23 factorial by 23. This entire number, remainder 1 a is divided by 13. So this is nothing but remainder 1 23 factorial divided by 13. 23 factorial is divisible by 2. This is divisible by 3, divisible by 4, divisible by 23. So what is left in the final question? 23 factorial should be divisible by 13. If it is divisible by 13, what will be the remainder? The entire question is this one. 23 factorial divided by 13. Now how to solve? Now how to solve this question? Now how to solve? Now see here. This entire question can be translated into, this entire question is translated into 23 factorial divided by 13. Now We will solve it. 23 factorial divided by 13. 23 factorial, what does it, is 13 a factor of 23? Yes. So 23 factorial, 13 is a factor of 23 factorial. So the remainder is 0. Remainder is 0. I hope it is clear, right? So you can do one by one all the questions, sir. Remainder 1. 23 factorial is divided by 13. 23 factorial contains 13, 0. 23 factorial divided by 2 into 13. 23 factorial contains 2. 23 factorial contains 13, 0. 23 factorial divided by 3 into 13. 3 will come in 23 factorial, 13 will come in 23 factorial. Remainder 1, 23 factorial divided by 23 into 13. 23 factorial contains 23, contains 13. Remainder 0. So answer for this question is 0. Very beautiful problems that we discussed today. Let us go one by one. All the problems that we discussed. All the problems whatever we discussed, we will again do a recap. Wilson's theorem. Today we are going to discuss all the remainder based problems based on factorial. So if the numerator is in the form of a factorial and the denominator is a composite number, I can use Wilson's theorem. Wilson's theorem is p minus 1 factorial plus 1 when divided by p is 0. Question based on this one. Shortcut is p minus 1 factorial when divided by p is p minus 1. Example, p minus 2 factorial when divided by p is 1. Example, p minus 3 factorial divided by p is p minus 1 by 2. One example. What if it is not p minus 3 factorial? How to solve it? By using this factorization method. What if it is more than 3 deviations, 4 deviations? What if denominator is a factor of numerator? What if denominator is a product of two prime numbers 19 and 23? Right? What if the number is of the form p minus 1 by 2 factorial whole square divided by p? 71 minus 1 is 70 by 2, which is 35 factorial. Another 3 questions. Summation n into n factorial is n plus 1 factorial minus 1. Questions based on that one. Questions based on this one. I hope the entire concept is clear, right? Reminder 1. P minus 1 factorial by p. P minus 2 factorial by p. P minus 3 factorial by p. Summation n into n factorial is n plus 1 factorial minus 1. P minus 1 by 2 factorial whole square divided by p. Remainder based problems. Entire variety of questions which we solved it. This is how we are going to progress in every class. We will take a topic, we will do all the problems under a subtopic so that my enrolled students will not get any doubt in any of this topic.